screen about a project titled A Two-Stage Model to Predict Surgical Patients' Length of Stay from an Electronic Patient Database. Coming to the introduction part, the implementation of this two-stage predictive model offers promising prospects for enhancing hospital management and patient care. By providing healthcare professionals with reliable estimates of patient lengths of stay, medical facilities can streamline their operations, allocate resources more efficiently, and improve overall patient satisfaction. As electronic patient databases continue to grow and evolve, the potential for this model to make a positive impact on the healthcare landscape becomes increasingly apparent, bringing us one step closer to a more efficient and patient-centric healthcare system. The first stage of the model involves feature extraction, where relevant data points are identified and processed to capture information, patient characteristics, and medical history. This step involves gathering patient demographics, medical diagnosis, surgical procedures performed, pre-operative conditions, and any complications that may arise during the hospital stay. So our main objective for this project ensures the model's adaptability to evolving patient data and changing healthcare practices. As new data becomes available, the model can be retrained and updated, ensuring its predictions remain accurate and up to date. This adaptability enhances the model's relevance and applicability across various healthcare institutions and patient populations. Ultimately, the objective is to optimize patient care and enhance hospital efficiency by enabling healthcare professionals to proactively plan and allocate resources based on predicted lengths of stay, leading to improved patient outcomes and satisfaction. The successful implementation of this model has the potential to revolutionize hospital management, paving the way for a more patient-centric and data-driven healthcare system. By learning from historical data on patient outcomes, the model can generate predictions for the expected length of stay for new surgical patients based on their unique profiles. The objective is to provide healthcare professionals with reliable and data-driven estimates that can assist in making informed decisions regarding resource allocation, patient flow, and overall hospital operations. Now coming to the requirements part, there are two types of requirements, that are hardware requirement and software requirement. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required for this project. Coming to the methodology part, first we have upload high dimension dataset. This step involves collecting and uploading a high dimensional dataset into the system. High dimensional dataset typically contains a large number of features or variables, which can pose challenges for traditional data analysis methods. Second, run PSO algorithm. Once the high dimensional dataset is uploaded, the particle swarm optimization, that is PSO algorithm, is executed. PSO is a meta-heuristic optimization technique inspired by the social behavior of word flocking or fish schooling. It's widely used to solve optimization problems, including feature selection and dimensionality reduction tasks. Third, pre-process and features correlation. After the PSO algorithm runs and selects the relevant features, the dataset undergoes pre-processing. Pre-processing involves cleaning, transforming, and normalizing the data to prepare it for further analysis. This step ensures data quality and consistency, which are crucial for accurate results. Fourth, run proposed VGS MOEA algorithm. Following pre-processing and features correlation analysis, the proposed vector generation strategy multi-objective evolutionary algorithm, that is VGS MOEA, is executed. The VGS MOEA is an optimization algorithm designed to address multi-objective problems where multiple conflicting objectives need to be optimized simultaneously. In this context, the VGS MOEA is likely applied to tackle a specific multi-objective task, such as optimizing accuracy and reducing dimensionality simultaneously. Fifth, comparison graph. Once the VGS MOEA algorithm runs and generates results, a comparison graph is created. This graph visually depicts and compares the performance of different algorithms or methods used in the study. Now coming to the execution part. To execute the project, first we need to open the code folder. Here this is the folder named as dataset. It is containing the training dataset and the testing dataset. This predicts surgical patient stay is the Python file which is containing the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload patient stay button dataset to upload the dataset. Select the length of stay dataset and click on open button to get the output. Here on this screen we can see dataset loaded and we can see dataset contains some non-numeric values. So we need to process dataset to convert or encode non-numeric to numeric values. Now click on dataset pre-processing button to clean and convert data to numeric. Here on this screen we can see all data values converted to numeric and we can see dataset contains 1000 records and 800 using training and for 200 for testing. Now the dataset is ready. Now click on run to state cart algorithm button to train all algorithms for getting the output. Here on this screen we can see misclassification error rate for each algorithm in stage 1 and 2. And on this screen we can see random forest error rate is less compared to proposed cart for cart using strategic techniques and random forest not applying. So by closing this window, now click on predict length of stay button to upload test data. Select testdata.csv file from here and click on open button to load test data for getting the output. Here on this screen in square brackets you can see the patient test data and after arrow symbol you can see length of stay as 7 days. And similarly for each data record you can see predicted length of days. Now click on CV error graph button to get cross validation error of each algorithm. In this graph you can see x-axis represents algorithm names whereas y-axis represents error rate for each stage 1 and 2. In all 3 algorithms random forest error rate is less. Now click on exit button to execute with the project. Now coming back to the conclusion part. In conclusion, the two-stage model successful implementation promises to user in a new era of data-driven decision-making in healthcare, fostering better patient experiences and outcomes while supporting healthcare providers in their mission to deliver high-quality care. With ongoing advancements in technology and data accessibility, the model's impact is poised to grow, transforming the way hospitals manage their resources and elevating the standard of patient care in the process. As the model becomes integrated into hospital systems, it has the potential to revolutionize the healthcare landscape, moving it towards a more patient-centric and data-informed approach. Hospitals can proactively plan and allocate resources based on the model's predictions, streamlining patient flow and improving overall efficiency. Ultimately, this leads to better patient care, reduced hospital costs, and an optimized healthcare system. Through learning from historical data, the model becomes adept at providing reliable estimates for the expected length of stay of new patients, empowering healthcare professionals with data-driven insights to optimize hospital operations and resource allocation.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.